Yeah. So on linear search, we're talking about, we're still dealing with arrays, but we're searching for an element. So now we're doing what we call searching. So we've got types of searching. We've got linear search and bubble sort and binary search. So one of these can come to mode. They can say write an algorithm for linear search, or they can say write an algorithm for binary search, or they can say write a pseudocode for binary search. Even the term pseudocode, when they say pseudocode, you're not going to write the code. You're going to write something like this. You see, that's just an explanation, but you'll also try to. So, but if they say the algorithm for binary search, they will be referring to this. So let's go to the linear search first and see how it works. So they are saying the linear search approach compares the key element key sequential. So this term is important. Sequential with each element in the array. It continues to do so until the key matches the element in the array, or the array is exhausted without a match being found. If a match is made, the linear search returns the index. So I've already wrote a code for linear search. I did the recording, I think also for binary search. I'm no longer sure, but between one of these, I wrote the code for it again. So now let's check our code and analyze what it does. Here, this is the class, right? This is how you declare. This is how you write the syntax. It's a public class. Then here you write the class name. Here is linear search. We were calling it linear search because you know that we want to search for an element. Okay? Then now you write public static. Instead of saying int there, now we say void, because we want to search through a list of numbers. So the variable type is int, obviously. So, and you must up here, what does our code start? Here we can also create, let me see how they wrote. They didn't write everything. Let me also check on this one, because they're also supposed to write the part where you output, but it's fine. Let me include it here. Here, before, you see that we have got a class, right, called linear search. Here, they should have created another class, but inside that class, public class, another method, inside the same class, and then they're going to say, inside this class, we're going to initialize our array. You see, array, and then 1, 4, 5. Just explaining so that you understand what is happening. And then you can declare your key value. Actually, this should be below, and this should be above. Let me try to see the one that I have here, because this one is not a full complete code of linear search. Linear search. Going to create your class, public class linear search. You must just understand how the algorithm works. Then I think if you can understand that, you'll be able to write the code. See how I wrote it, so that, because we have a lot to check here. And even the questions that were on your quiz, those algorithms, you should try to analyze them. If you don't understand, you'll ask me on my inbox. because I want us to also initialize an array. Because if you see on this code here, they only wrote the code that will search through the element. Oh, they actually did. They declared the array, but they didn't initialize, but it's fine. Even if it's like this is our method, linear search. Then here you'll write your parameters, right? Here you'll initialize your array. You can even say int array. You see, and then int the value that you are looking for, target. Then you close. Then inside your statement here, you can start by initializing our array like this. Maybe you'll just say here they didn't initialize. You'll just say list, it's equal to we must list the elements, right? What they actually did here. It will be int list, and then you initialize 2, 4, 6, 8. And then the next line you're going to write int target. If you are searching for 10 or for 6, you will say 6. Ne? So after that, you can create this, you can write this part. Then you'll say for int I equal to 0. Let me bring this close first. And then you'll say I. So this is just the syntax of you see inside this for loop. This is just the syntax of initializing our array and also declaring its length. So it will always be like this. Here you're going to say I is less than the array name dot length. It's always like that. I plus plus. Remember, let me go back here so that you can see. Remember, we've got what we call declaring an array. So when you declare, you only do this. You only do this. It's int the data type, the array name. So this is declaring, right? But we also have what we call creating an array, and also we also have what we call initializing an array. Let me see if they did. Here they didn't initialize. They just created an array. You see, now you can also declare in this way. You see the data type, the array name, and you put this. You can also put this here, but in Java it's not preferred. Then here you create your array. You'll say this is what we call creating. Then you'll initialize this to new double. Then here you write the array size. So it's exactly what they did here on this code, but they did that inside the for loop. You see, I it's less than list.length. They didn't specify the exact length. So that's how we can also write it in this way. So, but the algorithm that matters here is this part. Let me remove this. Now it's when now you compare. You are saying if you will create an if statement, then you will say if the target value, which is 6 in my array, it's initialized to the first element. You see, in the first element, which is what I is equal to 0. Then it should return what the first element. It depends on what you are looking for. You see, remember if I initialize the target value with list at I, you know that this loop is going to iterate. If I'm having 4 elements, 1, 2, 3, 4. If I have 4 elements, then it means the loop is going to, it means my for loop is going to check here. If it finds that the key is not equal to the target value, which is 6, it finds that it is not equal to the right index, then it will skip, and then it will skip until it finds 6. If it doesn't find 6, it will just return -1. I'm not sure if this makes sense. So the algorithm that you guys will know is this. It's this one. Must just know this part. If you declared a key as target, you're going to say target is equivalent to list at I. Remember, I will be updated to 0, 1, 2, 3. So we know that our target is at index number 3. So our program was going to print what? It was going to say 0, 1, 2. The output will be 2, which will be indicating that my value is at index number 2 if the target is found. Otherwise, it will output what? It will output -1. You should try to write this code for the linear search. Then I think you will be able to understand how it actually works. Then the binary search, again, when they say write the pseudocode, if they tell you to write the pseudocode, so this is usually 4 marks, 4 to 5 marks. Even the binary search, they share the same marks. You see, let me first start with the pseudocode before I. So on binary search, you must know the difference here. This one is less, it's not fast, it's low. When you compare it with binary search, it's low. Yeah, the searching algorithm is very slow compared to the binary search. I think binary search, just that I forgot. This one, I think it uses ON squared, and this one it's just ON. So this is what we call the big O notation. You're gonna learn it to in chapter for test 2. You are just comparing which algorithm is more fast. Obviously, if I'm saying N squared, it means the algorithm is more faster than ON. You see, ne? And then we also have what we call O1. This one is constant time. It means your algorithm doesn't change, it remains constant. So for now, just know that this one, the linear search is faster, is lower than the binary search. Reason being, this one for linear search, it runs the code sequentially. It checks element by element. You see, ne? To check the key value if it's if it is actually there on your code. Otherwise, if it is not there on your array, it will return -1. So that's how it works. But with the binary search, if I have an array, let's say this is our array. Okay, 2, 4, 6, 8, 10, 12. So this has got 13 elements. So the binary search was going to have this array, meaning we're going to have 6 elements on the left, 2, 4, 6, and also it will take these ones. So it's going to first it's going to check the lower half and also check the upper half, and also check if this one is equal to the target value. So you see that this one obviously is fast, because it doesn't compare element by element. With linear search, it checks one by one. You see, if the target value is there. So that's the difference. Then the algorithm. Oh, before I go to algorithm, the pseudocode, you're going to say, if key is less than the middle element. Key, remember, is the target value that we're looking for. If it's less than the middle element, you need to continue to search for the target only in the first half of the array. Now, if the value you're looking for is equal to the middle element, the search ends with a match, and then you'll stop searching. The algorithm will stop searching, meaning your for loop is gonna terminate. And then if the key is greater than the middle element, you need to continue. If the target value is greater than the middle element, you need to continue for the search in the second half of the array, meaning you must continue searching on the other side. So this is the algorithm for binary search. So we've got two versions. It's either you write it in this way or write it in this way. So I don't know which one do you guys prefer. Let's check the difference between this. The root exactly, oh, it's not the same thing. Why not -1? This and this is the same thing. Ne? It's just that here on this one they also include that return -1. So we should focus on this one. So here is you'll start by initializing, or you'll start by creating a class. You declare your parameters, right? The same thing you did. You just change it to binary search. On linear search, it was linear search. You see, ne? Then here you have your two parameters, and then you start. This is where your code starts. You'll say the lower is initialized includes 0. And then the highest value we're saying is list.length -1. You see, ne? Meaning if I have 1, 4, 6, 9, if I have those 4 elements, we're saying that the binary search should stop here. It should stop searching here, the highest value. Why are we doing this? We don't want to have an error such as index out of bound. Remember, if it comes here, it can no longer compare this one with anything. You see, hence it must stop here. That's why we initialize this one to list.length -1. Then now we're saying while this value here is greater or equal to the lower value. So our algorithm is comparing the lower and the last element before the last element. So it says int mid. So this is the formula that you must know, that it will be like this. Even this is 5 marks, guys. If it comes, make sure you take this. And then you'll say int mid. This is the formula, right? So make sure that when you write this part, you say int mid, the middle value. You'll say low agar plus high. You see the brackets. Don't remove them. Don't act smart. Then write it in that way. If you remove them, there is a high chance that is gonna, yeah. And then you'll have what? If the key is less than the middle element. Now this is the comparison. Okay? If the key, the target value is less than the middle, meaning that in this array, I should be having 5. Let me put 5 elements here. Let's say the last one is 11. So the middle element is 6. We agree, is 6. So we're saying that if the target value, let's say we're looking for 6, actually, let's say, yeah, let's start by looking for 6 because the middle element. So if the target value it's less than the middle value, meaning that if the value we're looking for it's on this side, you see, if it's on the left, then what will happen? Then the largest value, then high it's updated to mid -1, meaning that now the highest, you see, the highest was here before on our initial program when we started on this part, but now we're updating high to what? Updating high to what? To mid -1, which will be on this part, mid -1. So why are we updating it here? Because the target value, if it is this side, again, it means we want our code to search only the lower half. So this part of the algorithm, actually, let me try to not write a lot of things. Don't want to confuse you. So this part of the algorithm here, the if statement, this part, we're updating the high to this position so that we can compare the element, the lower half. So here we're comparing. Let me reduce this. Or comparing the lower elements. Or comparing it with what? With the target value. You see, with the target value. Then the else statement, it says if the target value is equal to the middle value, which in our case is true. You see, the middle value, it's equal to the target value. Then it will return what? The middle value. It will just return this. Remember, when we say list mid, we are referring to the content. And the content of the middle value is 6. So our program will return what? Actually, we're not referring to the content, we're referring to the index. So our code was going to return 0, 1, 2. It was going to return 2, which means the middle element is found at index number 2. Otherwise, it should check the upper half, mid plus 1. It should come and check that side. Was the binary search making sense? Otherwise, if it doesn't find anything, it will say not found. So you must also know how to write this, meaning you're going to have your if statement, else if, and then else. You are also allowed to else if. I know you are not, I don't want just write it in this way. Because if you try to alter it, you might end up writing other things. I know you guys, but I think you can also if, else, if. Yeah, you can also put this here up, then this one below. It's not a problem. It will still run. You have just you just let me also check something here. Guys, I hope everything for now is making sense. Any questions so far? That's just how we analyze the searching matter. Okay, I don't see no one asking, so it means this one is fine. So this is how, okay, before I explain this, let me first confirm something on binary search. Binary search, ne? Guys, my devices are very low. Let me unplug this one. It will charge. Before I move to sorting, I want us to add something. Remember, this is our class name, né? This is our method, binary search, and then here you're gonna pass parameters. The same thing, even on linear search, you're gonna write that exactly. Then this is your code, your algorithm, right there. Good. Yeah, so now, yeah, this is what I wanted to add, né? Started they use, okay. Remember, you can also use a scanner class, but it will be more challenging for you guys. If you wanted to use the scanner class, you're going to say import java .util, then you write the scanner class, scan again. Then obviously, if you want to input, it means you must create your, this one is your first method. Then after closing this, here you're going to write, you're going to come and create the other method. This is what I wanted to explain. You can say public static void may. Remember, if you just write this part, your code is not going to return anything. It will just be there, because you must also include this. There's public static void, meaning you must have two methods, the main one and also this one. You see the binary search. So now on this one, the second method, remember this is it forms part of the syntax, right? So if this part is not there, your code is not going to run. You're not even gonna see what's actually happening. So now we're going to say, now we're using, if you are using a scanner, you'll say scanner input equal to new. This is the syntax. Or maybe I should write this. Let me write this on a new page so that you understand. Remember, you're gonna say import .java.util .scanner. Then you close. Then you'll say public class binary search. This is your last name, and you'll create your method public static int. Then binary search, you can call it binary. The method name, you can name it anything. Then you will pass your array. Let's say it's list. And then int target, I'll just say tag. Then I create this. So here you're going to write your algorithm. Again, you'll start by initializing int low equal to 0, int high, it's equal to array dot length minus 1. Then you'll say you'll create a while that compares the lower elements with the high element. And you know that high is initialized to the second last element. Okay. Then now you'll have int the middle. You create that formula, and I said you must put this plus high divided by 2. This is just for your array to be divided into lower half and upper half. Then you come then you're going to come and do what after. You're going to say you'll create and can create a new statement if the middle element it's equal to the target tag, then it can return the middle value. You agree with this one. Then else, if the array mid is less than the key u is less than the target, again I'm writing it's less than the target value. If it's less than, if the middle element, again it's a less than, meaning that if you are finding the target value on the left side of your array, then this is what the code should do. It should update the low to mid plus 1, meaning if the target value, actually here I explained it wrong. If the target value is found above the middle value, then it will check the upper half. Hence we're updating low to mid plus 1, meaning that if this is my array, let me create an array so that you can see. Let's say this is my array list, or let's just call it array. If this is my array int, and I initialize this to 1, 2, 3, 4, 5, 6, 7, 8. Ne? This will be the lower. Remember, initially low was here. But if the target value is found this side, it means low will be updated to mid. This one is our mid. It will be updated to mid plus 1. You see, ne? That's what it means on this part. Otherwise, then you see else the high, which was here. Remember, high was initially here. So high will be updated to middle minus 1. So it will be mid minus 1. You close, then you are done. Otherwise, your code will return -1. I close again. Now I create the second method so that I can output. So if you don't write the second method, it will depend on how the lecturer asks. If you also want you to show the output, then you can write it. Remember, this code is just the algorithm part. So if you write this, I think, or on Visual Studio Code, it will just show no errors and not output anything, because you don't yet have an array, right? But I think it will complain because you won't have the main method, isn't it? It's gonna complain because you must also include this one. I think maybe if you say public static main, no, static void main, because this is the part of the syntax. Here I don't have to pass any. Oh, and then here you say string args. So this is the syntax, string args. Then here you'll write you'll initialize your array. Let's say we say int num, call it num. Or let me check something. It won't run. You see here I called it list. So even here I must call it list. And then I can initialize it to whatever elements however the number of elements I want, right? So I just want you guys to actually see, or let's just say 1, 2, 8. Let's just say we have that. Then you can pass this method, which is called binary, on the second method, meaning I'm allowed to say int, it's binary, so that my code can know that I have created another method there. So this is what calling the method, right? So we can say int. Okay, we can even say, let's first create a variable and say int x, it's equal to a binary, then method name. Then I can say must pass the parameters, right? So I'm comparing list with what? With the target be. I'm using tag. They will say tag. So this is just what we call calling the method. So this kind of things is some of the things that you should teach yourself, right? Because there is no way you'll ever understand how to code without. But you must study the algorithm. Data structures is about the algorithm. I know some of you can code, but you find it difficult to understand the algorithm. So study the algorithm more. Yeah, and then here, if you want, you can now print the elements in the array. You can just say system dot out dot print len again, and then you will see element found if it is found, and then plus x. But what I need you guys to know, because this is what they can bring in the test, they'll just say write the algorithm for binary search. So you must know this part. The first, especially this part. whatever is inside this, the first method for writing your algorithm. And also this is included, right? Remember here, even if you write this, you put parentheses, you don't write anything, your code will still run. Yeah, so this must be there. So let's go to sorting. Sorting, they're saying it's like searching. Again, it's a common task that we use to sort elements. So this is how you must just understand how it works, and then you'll understand the code. If you don't understand how it works, you will never understand the code. So this is the array, né? So what it does, it swaps the smallest elements in working. It finds the smallest and swaps it with the largest elements. If you check here, it is swapping the first element with the smallest element on the right. It puts it here, and then it checks again for the smallest element. It is 2 now, right? And then it updates to 9, meaning you'll be having I, you can have I and M. So now I will be updated to this, meaning it's I plus 1. Hence, you'll have a for loop. I plus 1. Then it finds the another smallest element, in this case is 2, and then it performs the swapping. Now it swaps 9, and 9 comes here, the 2 comes here. You see, in that way, it finds the smallest again, which is now what? It's 4. It swaps it with 5. Hence, we have this. Then it finds the smallest element again. It checks there. It finds 6. You see, and then it first checked 6 and 5. It realized that I can't search 6 is greater than 5, but it realizes that I can now update to this, meaning this probably I plus 3 or plus 4. I'm not sure, I wasn't counting. Then it will update, it will swap this. So that's how the selection sort works. That this one is for selection sort. So they can ask you to write the design of the selection sort. So I wrote the design for you guys. So, but the thing is, I'm not sure if you understood. But you must first understand this code. Then you can know how to write the design without actually referring. Because it will be difficult to write it without you knowing that. Remember, one of the basic things is that it must find the smallest element, right? Number 2, selection sort must perform swapping. It swap the smallest with the values with the next index. Swap the smallest element with the next index. Yeah, I can explain it like that. So here you have a class name called selection sort. Now you create your method. You can call it whatever you want. You have a for loop. Now even here you stop you'll say list dot length minus 1. You want your code to stop searching here to avoid having an error. Remember, Pella, it checks this element with the elements that are on the right of it, so it cannot come here. So we must say list dot length minus 1. So whether you are dealing with binary search or linear search or sorting, you must always do that. Yeah, I think there is a page I must remove. So are you guys fine for now? Then now we have this. This is our method. Now below this one, obviously, just that yet they decided not to include it. They just wrote the algorithms right on your textbook, which is what they will look for in your test. They want you to know how to write this. So this is the first algorithm. Then this one is the second. Oh, this is not an algorithm. We're just initializing. This one is the second algorithm. Just those two. So this code, the first algorithm is for finding the minimum in the list. It searches for the minimum element and passes it to J. Now when the loop loops again, you're gonna have what? Meaning this, we know that it means if you see here, they declared J as I plus 1. On the first for loop, it's I is equal to 0 again. So let's start here. Remember, I must analyze the algorithm going down. Let's start on the first for loop. You just have I equal to 0. And you declare your minimum value. So here you can also say double min. It's initialized to list at I. And then you say int int what? This is the index again. The current index, it's I. So there is a difference between these two statements. Here you are declaring, you see double minimum value is equal to list at I. You are initializing your minimum value. You are initializing your minimum value to the first index in your array, meaning you are initializing the minimum to this. You are saying this is minimum. I want to name it the way they named it, current minimum. Current minimum. And then int current minimum index. You see, they're saying int the current minimum index is I. Okay, so they're just saying that. On the next statement, they're saying int current. So this is a second variable, current. I can say current minimum index. Let me write it the way they did so that you don't forget. Minimum index. This you initialize it to 0. We are just saying that the current minimum value is found at index 0. That's what you are doing there. Nothing more. Then now you create your for loop. Again, remember, this is a for loop as well. So the minimum index won't always be at position 0. On the next iteration, I will update to 1. I will update to 2. I will update to 3. Jalo njalo, until you are done comparing the smallest elements with the values with the next value. So it compares like this. Remember, you have 2, 4, 6, 8, 10. This is the minimum. This one is your J plus 1. So it will always compare these two. After comparing, if it finds no problem, it will remain. This one will remain here, but this one will skip. But if it finds that the order is unsorted, let's do an unsorted list. As let's start with 10, then we'll say 2, 4, 1. So it's going to first compare this minimum with this, which is your J plus 1, right? And then it will perform the swap P, which is this part, which is the second algorithm. This is where it performs the swap P. So the minimum index, when they are saying when the minimum index is not equal to I, list at the current index will be initialized to list at I. And also list at I is equal to the current. Here is the one. Here you must create a. Let me see. Let me check also the insertion sort because I don't want to mix these two. The insertion sort. Where is it? Supposed to be here. Because there is the one where you must create a temporary variable so that your code doesn't overwrite the value. I'm not where I passed. Does this have and you must also check a term called the rect the array. I saw it here on this prescribed book. Must check what's the difference between a normal array and a rect array, but I'll also show you. Yeah, this is the algorithm that performs the swapping again. But I also want to confirm with the insertion sort if they wrote it. They didn't write it here. So there is no difference. There is not a big difference between selection and insertion sort. Just that I'm not finding the code. Let me check here. I think I have code. So they can ask you which one is fast. Which one is faster? Which one is faster between the selection sort and insertion sort? But you won't know until you see how this one also works. Okay? So, where is it? Anyone who knows where the insertion sort is on this guide, because I haven't been really using it. The insertion sort. Yeah, I'm not finding the insertion sort, but none of them is faster than the other one. They have the same time complexity. Yeah, so with this, remember I first, when I did the linear search and binary search, I said this one, it uses ON squared time to complexity. This one, it uses ON. I think you have seen this in previous question papers. So this just refers to which one is faster. You see, there will be somewhere on test 2, they're going to draw graphs. We're going to have graphs. This one maybe will represent O1, ON squared. You see, this will be representing the time complexity. So you must know which type of searching is faster than the other one. So for now, we'll just focus on these two for your test 1. And then also on sorting, you must know which one has the best time complexity. So with insertion sort and insertion sort and selection sort, they have the same sort. They have the same time complexity. So you must know the difference. This one, it performs more swapping of elements. Remember, it checks more swapping, ne? This one less swaps. You know why this one performs less swaps? Because it just finds, this one, it just searches for the what? For the smallest element on the right of your array. It takes it and it just inserts it there. It finds another one, it finds another one, it put. So that one, it compares one by one, you see, ne? So that's why the insertion sort, I'm saying that it performs less swapping. You must know these differences. For the purpose of your test, they can ask such if they want. So is someone saying that they have network problems? They have network problems. Ish, yeah, ne? Yeah, Kumo, now it's back. Let's continue. Guys, don't make sure your network is fine. Now we'll be forced to go back and check this recording. Because even those that didn't attend, they'll have to check this. So I think I'll try to explain. I wanted to explain the selection, the insertion sort. Is it here on your slides? I don't think it's here. Let me just check. Hopefully, you guys will understand how these algorithms work. Ne? Is there anyone who doesn't understand how this works? Because this slide we didn't really focus more on it because I assume that you're gonna check it. This is your first slide. But I'll try to explain it as well. Linear search. Yeah, you see, this is how the linear search works. This you are looking for. If you are looking for 3, it will go. It will check here. You see, ne? Check the next one. So this one it takes time, then until it finds it. Otherwise, it will return. The code will just return -1. Let's come to then this the binary search. You see, ne? I even draw the circles for you guys. This checks this side, then this one, and then it also check the upper half. This is the right, this is the left. Is there anyone saying something? Then this is the selection sort, exactly the way they draw it on that. You see, ne? They took whatever here, ne? It's on that guide that they give. Unfortunately, I found it late as well. Someone sent it to me late. I thought maybe you guys don't have the prescribed book. So I didn't want to give you something that is out of your syllabus, you see. Hey, what is the insertion sort here? I think it doesn't have insertion sort. Selection. Yeah, and I think this one, it explains it nice. So this code here, is there a question, guys? I think there is someone who's saying something. Is there anyone saying something? I'm looking for the insertion sort here. Let me go to the other slide. Maybe it has the one for multidimensional. You can ask if you have questions. Because single, I'm looking for the one for multi-dimensional. So you guys say this is not gonna come, so it means I'm not gonna check. I'm not gonna check the sets queue list. But I think I saw something on. Let me first. Okay, this is just the table interfaces implementations. Okay, but you should know, guys, you didn't do this, but it's fine. You didn't do those for now. It means it will come on test 2, meaning you guys for test 2 you must really prepare. You see, when I said that they can ask about those things, that I'm not lying. Question 2, I think all of you should know it, how to answer this. The binaries, you see, they can ask for an algorithm. You see, so don't go there without knowing them. And then, but check more for binary search and linear search, and also check the difference. This was the difference, I think. The linear search compares the key elements sequentially with each element in the array list. The method continues to do so until the key matches an element in the list, or the list is executed without a match being found. If a match is made, the linear search returns the index of that element. So if you are searching for 10 and it's at index number 9, it will return 9. You see, the same thing with binary search. So the binary search, this is what it does. It compares the element, compares the target value or the key element in the middle of the array. If the key is less than the middle element, you only need to search the target element in the first half. If the key is equal to the middle, the search will end there. If the key is greater than, you only need to search the key in the second half of the array. You see, that's just the difference. Yes, and we have what to call, and then they say the binary search method returns the index of the element in the list that matches the search key. Otherwise, it will return -1. Yeah, that's the description of what actually happens. Is there anything I'm leaving? Then you guys know the difference between the advantages. What was this? I think this were the chances of wastage of memory. These were the disadvantages of arrays. The first one, wastage of memory space if the elements inserted in the array are less than the allocated size. So if I create an array, in that way it's fine. 1, 2, 3. So if I create an array and say new array, okay, then we say 10 elements. This is what it's creating, an array. You see, let me also show you here on this slide. I want to come with my new weights and confuse you. For declaring and creating. Yeah, that's whatever I did there is declaring and creating an array. Let me go back. So I have declared that my array is arr, it's equal to new array, then the array size. Now the array are fixed the size, you see, ne? But if now I initialize my array and say array it's equal to what? If I initialize this, do we include this, the square brackets, or should only take the type, the name? Do we write it like this after this statement, or do we write it like this? Yeah, let's communicate a bit, guys. You should also comment on these things because they're gonna move you to write the wrong things there. Should I write it like this or the second way? It's fine. 1, 2, 4, 10. 1, 2, 4, 10. So you see that this says I fixed it to 10 elements. So if I write less than 10 elements, I have wasted the memory space. Which one is the correct way of writing it? The first number 1 or 2?
Number 2.
Number 2. But you sound like you are not sure. Let's go back and I show you something here. I wrote a lot of stuff here because I've used this before. Yes. You see this? This is declaring, which is this part. And creating, right? and initializing in one step. Okay, this is just the shorthand. The other way of initializing elements one by one. So when you do this index 0, just like in C++, this will be, you initialize the first element to index 0, 1, 2, 3. And that this is also allowed, you see. So now, as we are having this part, right? Now I want to initialize them in one line, you see. So you must write it in this way. No, but you cannot redeclare the array. So yeah, hence I'm asking the question that do we exclude the data type and write? Don't we do this? We just write this, you cannot come. I don't think you should say by list and then you do this again. No, I think we should. I already know the array name. It's my list, so you just initialize it to the equivalent elements because the program already know the data type. You see, no. That's wrong because it won't know if it's an array or what. You see, it will initialize it as just a variable. So yeah, you are right. It will be my list, and then you do this. Then you initialize because this is an array. Remember. Hey, your slide. Who compiled this? I thought I'll find a program that actually write it in that order. And also check the one for random shuffling. They hardly bring it, but you can also check it out. Remember the random shuffling, it uses the maths random function. So yeah, just know that you must, this is the algorithm. And it also performs random shuffling. It also performs what? A swapping of elements. So you must analyze. Remember, guys, to know this, to understand this, how this works, you must analyze your code from here going down. You cannot start analyzing from here. You won't understand. Temp, here it's used to store a temporary variable for my list at I. So it's gonna store somewhere. Hence you have this table. I think that's why they drew this. And then you see, after they've compared, you see the last part, now they update my list at J. Since you see the second part, they are equal. If we find that my list at I and my list at J are equal, then you say my list at J is equal to the temporary variable. So when you say temp, you're storing the variable somewhere, then you'll bring it back when the condition is fulfilled. So here they created a for loop, generate an index J randomly. This is the math function, my list at length. So remember, this is the math. It's int at J int m u. It's int m, the math function for the random. This is just how you write the random function. So the Java Virtual Machine, it already knows this. Hence you won't encounter an error. My list dot length then you close. Here for my list dot length, they're just talking about the length of your array. So what what this does, it randomly shuffle elements in your array. I'll give you an example. Times 100. So I think there was a question asking you to write that on this question paper. Where is it? This question, they were saying initialize an array with random variables. So the array name was my list. So you're supposed to say my list, you see, and then you initialize it to what? To maths.random times 100 or 1000. You can even say 10, or you can say the array size. Array size, depending on how many elements it will store. But let's just keep it in this times 10. So you should try to write a code for this so that you see what will happen. If it was a matrix, 1, 2, 4, 5, 7, 10, it was going to shuffle these elements. You will find that it writes them like this: 1, 2, 7, 5. Can even duplicate them. And if it was 100 here, it will do this. When you write the random, you should try to do it, you'll see it. It will print elements that are between that are what, 99. It will print elements that are on there. This is the 10th or the 100th term. 100th. How do you guys name these things? If I have 10, 100, 1000, 10,000, I forgot how you say it. This is the 10th, né? This is the 100th. I don't know. And then this is the 1000. So if it was 100, it was going to print elements with 2 digits randomly. That's why we use the random function. Maybe 56 in that way. A code for printing array elements, you guys, you already know that it will be system dot out dot print. Remember, if you forget out, you will get 0. So you must fill these things correct. Print lin, then you print array elements. You see the array elements are plus, if you have declared, if you have initialized them, you'll say whatever you initialize them to. Okay. Usually it will be the name of the array is my list. It will be my list. Then you do that. Then it will print the elements in your array. Then the one for summing all elements in your array is what you'll say, since they initialize total, you'll say total, it's equal to total plus my list at I, since they are using I there. See, these things were very easy. And this is the Java scanner what. So this is the syntax, you see, the scanner what. So they say initialize array with input values. They know that people they don't know how to input using a scanner, you see, So how are you guys gonna write it? So they wanted you to input using a scan. Initialize array. Okay, so it means it will be the array name equal to, it's going to be what? It's a new scanner. It's new, the class name system.in. Is this the right way? Hello, guys, is this correct? That's what they wanted. New scanner system.in. This is allowing your scanner to input values. If they specified initialize an array with integer input values, I think it will be new int scanner system.in. You see, and then here for this one, you know that finding the largest element, the code that will find the largest element, you compare the elements in the array if they are greater than the maximum. If the elements are greater than maximum, the maximum will be updated to what? To my list at I. This was easy to those to that element. Meaning, if you find an element 100, you find that is the largest. The other ones are small. Obviously, to update to list at, if this is index 0, 1, 2, this is index 3, it will update to my list at 3 will be equal to the max. I don't know if I was supposed to remove this. Let me try to create. Guys, I hope this is making sense a bit. I asked you guys to write the design of the method for the selection sort. You never practiced that, ne? Let me open. Yeah, guys, you'll have to watch the recording because I'm using different question papers here to explain some of these things to you. You see, ne? I'm teaching you how to answer questions so that you don't get lost when you have to answer. Remember, I want to remind you something. If they say this is looping, if they say write a syntax for the scanner class, you should be able to do it, and also for the J option pane. So let me start with the J option pane syntax for, let's say, for printing a message. So you'll import is JAVEX, right? JAVEX. Here we use JAVEX. Remember, there are many packages, right? This is one of the packages. Import.javex .swing .j option pane. It will be in capital letters. J option pane. Pane. It close. Every statement in Java, it ends with a semicolon. Then you'll say your access modifier public. Remember, this is called an access modifier. We also have what we call protected, and we also have what? Private. So the objects declared on the private, they're unaccessible. Okay. Then you'll create what class. What am I writing now? You'll say public, underneath that public class J option pane. That's just the class name. You can name it anything. You can even say pane. But let's just keep it in that order. J option. Just don't forget that the file name should be the same as the class name so that you don't have problems. Guys, is everything clear so far? Because we must also try to do a bit of compiler questions. Can you all say public static void main string? This is our method args. So I'm writing the syntax so that if they ask, you don't get it wrong. Then here you'll say what? You'll say the data type, then the variable, you'll initialize it to J option pay. J option pane dot show input dialog. Input dialog null. Yeah, I'm not gonna write anything there. This is where you write your string. Please enter this. Please enter the number. Yeah, you see it. I wanted to write this in one line. Increase this. Don't have the font. I'm going to increase the font of this. Right. Let me just leave it. Data type variable J option pane show input dialog, right? Then the next part you are going to say the class name. The class name meaning it will be J option pane dot show message dialog null, and then here you'll say whatever was there, and then you'll have created your variable here, and then here it will be variable one. Yeah. So if here I wrote something like please enter your name. Okay, let me just say please enter your first name, and then here I come and say hello. So the message dialog that will be printed, it's going to create a box, this thing, and then it will say please enter your name, ne? Just want you to see how it works. And then it's going to create something like this, and then when you print, oh yeah, and then you'll have what? You'll have hello, and then the variable name. Do we initialize this? Oh yeah, you'll have please enter your name. So here you're going to enter your name. It will allow you to enter your name. I think the output will be hello and then that name, because you have also created another string there. You see, so you must try to do the J option pane. I think I've done it online. So guys, is there any question? I think now your duty is to go and analyze and we forgot the scanner, ne? The scanner class syntax. So if they say write the scanner class syntax, how are you guys gonna write it? Because they can bring this, guys. It's very possible. Again, they'll say import, because they've taught you during practicals. So they can ask just so that you get it wrong. This is the scanner class .util.scanner. So this is the Java package util. The other one for on J option pane, if you saw, is .swing. Let me come here. This is under data structures because these nodes now, they are a lot. So guys, here it's about me guiding you what to know on data structures for your test. Then you'll create your class public class. Then let's say we say Bongani. Then I can come and say public static void main string, then args. This is the syntax. Then here you'll say scanner, the class name, then you create your object, then new scanner, then system.in. So here you're just telling us your compiler that I'll want to input something at the end of this code. So this is the syntax. You see, short and straightforward. And this one is the one for this one is the one for J option pay. Yeah, this one is a bit longer, but it's about understanding what's actually happening. Just have to know that here you'll say something like int x. You initialize this to the class name. Okay, and then you say show input dialog, and then you write. Yeah, even this is simple. Okay? You just have to write it down on your notebooks. Then and also this one. Any question so far? Yeah. Can we go to compiler now? Or we should end the session here and then you guys will consult on compiler. This is 2025. Do you guys know how to answer 2.2 and 2.3? So which method do you use to test if an element is in a set or list named X? Guys, which method do you use to test if an element is in the collection interface set or a list? What's the name of the method? This I was expecting you to already give me an answer because you already had this. Remember, I can't skip to the exam papers are doing this one. You must first do this one and make sure you know it. When I say make sure you know it, I mean know how to answer the application as well. So which method do we use to test if an element is in a set or a list? And we're referring to in. Okay, so this is the chapter that you didn't do. I think this one come. Yeah, because it falls under the that list set and cubes, which is chapter 3. So if you're saying you didn't do that, it makes sense that now for now you don't even this one. But I think here we're supposed to just add because they are saying list. You have list one. List one is that list two is that after list one dot add all at list two. What are you gonna have? So I think with a list you can have duplicates. You must check the properties. So you must answer it, I think, in this way. If it doesn't have duplicates, if a list doesn't have duplicates, you'll have 1, 2, 3, 5. Why did I write 3 2 times? This will be 5, 6, and then this will be 5, 6 as well. If it doesn't have duplicates, it will be like that. So, but this is under chapter 3. So I think I'm just answering it for the sake of the lecture surprising you. You guys know how to answer this question now? Because you never really answered it for me on the last class.
No.
Hey, you still don't know it. Yeah, you have a problem. Guys, are you even studying? Hey, don't. Guys, don't come back with low marks. Make sure you nail both parts. Because I've taught you enough. Just didn't. Some of you are not attending, and you're not writing the exercises I was giving you. And also this one, you must know how to answer this. Recognizing a transitional diagram that will recognize words, keywords, and identifiers. Identifiers were referring to the words on your line of code. With keywords, we are referring to referring to even the numbers, the operations there in your code. That's the group of keywords. So, where do I start? Let me start with this one. Difference. This one you cannot go without knowing it. Should make sure you know how to answer that. So I'm gonna start at where should I start? I must answer everything. And I hope you know how to answer this because it's also gonna be part of your test. Even or odd will be there. I said this structure here. If you can understand everything here, I think with compiler and know how to draw the transitional diagram for. There is also a transitional diagram for drawing white spaces. White spaces. So you must know both diagrams. So I can say, guys, where do I start answering? 1.2 or 1.3?
1.2.
Yeah. The one who answered it shows that you are not studying. You should be knowing how to describe this. But it's fine. Let me just answer for you guys. If you come back with low marks, we're gonna have a problem. 1.2 again. 1.2 epsilon A B asterisk. Describe the language. Okay. And they like this, ne? I think we must end this class around 7:30 so that even those who want to consult one-on-one, they can find me around the library because I also have another class. So maybe I'll finish my classes at 8:30, then around 9, I'll be around campus. So you can also come and ask Inyana there. Because some of you, Galiti, we were not studying at all. So this will be epsilon. The first we're describing, right? So you describe by writing the full, the most possible answers, and then you explain here after. If you don't write everything, even the lecture will give you full marks. This is how many marks? 3 marks. So the first mark, I think it should be, the first two, I think it should be here. And then the last one will be from you explaining what is actually happening with the language. Now, we're gonna say, we can either pick an epsilon or an A. So you can have an A. And then now we can have what? I've completed this part again. Now what's happening is that I cannot write A alone. Why? My regular expression will always end with a B. Remember, there is this B here. I cannot ignore it. So it must be AB. I come, and check the regular expression again. So I don't repeat epsilon because epsilon is nothing. Don't do this. That's wrong. Don't do it. Don't only write epsilon once. Now you can have an A, you can take another B and another B. You see, ne? We can take an A. I want you guys to also cram a bit here. You can take an A and a B again. Now, because you have this asterisk here, it means you can repeat this statement again. The meaning you're gonna have A, B, B. You can repeat this 2 times. Whatever combination you got, actually, let's not start here. Let's start here. You can repeat these 2 times. A, B, A, B, A, B. You can also have this one, A, B, B, A, B, B. The 1, 4, 3. And I forgot a combination here again. What a combination. You can also have a B and an A. My question is this the same thing, guys? The arrangement is different, you see, ne? Is this the same thing? Okay, if I'm repeating this, I can have a B, A, B, A. You agree, ne? So this is the different things, because if I'm repeating A, B twice, I'll end with A, B, but here I'll end with B, A. So those are different combinations. Then what you'll do after, you'll do this. And also the other ones that you can have. And also can repeat this one 3 times. B, A, B, A, B, A. Yeah. I think this is it. That's the regular expression. So when you describe it, you are going to say, you can choose an empty string and the other strings should always end with a it should always end with what? With B, with a B. So yeah, this one is wrong, guys. You cannot start here and pick. This one is wrong, and also this one, and also this one. So I have to remove this. Your string must always end with a B. This one, it's the B, it's always at the end. So yeah, I wanted to see if this can actually work. So yeah, no, meaning that I cannot start with a B. I'm forced to always start here. Remember, this question here, you see the way we're answering question 1.2, ne? You're gonna have a challenge also on 1.7 if you don't understand what I got there. Because on 1.7 they wanted the path, all the paths labeled A. Okay, no, 1.7 is different. 1.71 is different because they just wanted the combination, all the paths that will consist of this. So yeah, we can analyze it the same way. So this one, you'll just say your strings will always end with a B, and also, and we can repeat the what? Let me put it like this: L1, L2 as many times as you want, or I should do this. Yeah, this will show you a lecture that you are actually studying. Ne? You should repeat. We can repeat the string. Let's say the string Must keep the language consistent, the string. This as many times as you can. I don't know if this makes sense. I once gave you an exercise based on this kind of questions. You didn't write most, it's only 1% submitted. Write a regular expression definition of all strings of A and B's with an even number of A's and an odd number of B's. You see, ne? They want even numbers of A's and odd numbers of B's. This is 1.3. Hey, this is not writing proper. 1.3. I'm having want A even numbers and we want B odd numbers. So I can come and create this combination here. Remember, odd even numbers we're referring to 2. Even 0 is an odd number, but obviously I'm not gonna start at 0. It will be 2, 4, 6, 8, 10, exact. Then odd numbers 3, U, 1. So even if you are starting with 3 B's, your string start with 3. B's is 5. 3, 5, 7, 9, 11, etc. Now, when I draw the string now, the regular expression, remember we're looking for the regular expression that will consist of even A's and even B's and odd B's. So I'm going to, I can create it like this and say I have, this will be my first answer. So you guys, you can also think of another one, okay? This one is the one that I was able to find. And then this, you can repeat it as many times as you want. You can have you can have an epsilon if it's a, if we're talking about an NFA, because it consists of epsilon moves. Remember, DFA, no epsilon moves. This is just the basics. We are not converting anything here. Don't say I taught you how to convert things. Ne? I haven't taught you that yet. And I don't think that will come. AA, we can have AABBB. That will be the first string. I can have AA, BB, BB, and a B. How many? 2 A's, 3 B's, 4 A's, 4 A's, 5 B's. You see, ne? Can have AA, B, 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 B. 6. Hey, this one is wrong now. 2, 4, 6. They should be 7. Because it's gonna, yeah, they should be 7. So here there are 7. I got 7 B's and you have what? 6 A's. So we have this combination. And exact, the string can continue, meaning the next combination is going to be 8 and 9. You see, ne? Is there another way of writing this? Let me try to create a simple one, because this one it's a little bit long, but it's not hard. You can say you will always end, okay, if I say we'll always end with 2 A's. Let me try this. Let me try this one, if you can get it. A. Let's repeat the number of A's as many times as you want, followed by an A, always. No, this one will be a problem. Because if now I choose 3, will I always get 5? Yeah, I think this can work. A asterisk A, B, 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 asterisk B. Now let's check this one. I can choose as many A's as I want. Okay? Epsilon, let me first choose one A. Then I'll have an A. B, B, and a B. And then I can choose as many A's as I want. Let me now choose 3. And then have another A, B, 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 B. Yeah, you see, even this is correct. Are you guys able to see? Understanding this? Can choose 4. Oh yeah, I chose 3. Yeah, now I can choose 4. Then there will be 5. Yeah, no. Now it's a problem. Ne? 2, 4, 5. Yeah, it's unless maybe we end. If we end with another A here, do you think this can work? Let's try it for the last time. A, you guys will go and try as well. B, 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 A. How many are they? It's 2. I chose 1, 1, 1. Okay, let's always end with A. Then left A. Then I'll have A. If I pick 2, A, B, 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 A. This is 2, 3, 4, 5. No, this won't work. Guys, we must go and try to get a simpler one. Eh? I think maybe that one is the simplest one we can have. This one. Yeah, and now if you add more, then it will be more complicated. But you should try to reduce it. Maybe one of you will get it. Then let's do a transitional diagram that will identify keywords. And okay, let's add 1.31. If they say draw a transitional diagram that identifies white spaces. I don't have my book with me here. I forgot how to do this. I have a forgetful mind. Ne? You're not mindset. Mindset. Then now can repeat this. The limb. I forgot how it's. Try to check. So I'm going to explain what's the limb. Let me try to get notes I wrote. Interaction between. Okay. I'm gonna add also 1.31. Eh? So I'm just giving you possible questions on compiler that they can ask. Because you have already failed to answer the questions I've been giving you in class. So now I'll be giving you what I think can come. And also check what to call, but I don't think they didn't teach you top down and bottom up passing. So yeah, don't study it. But if they come, they don't blame me. Ne? Some of you are not attending because they delay a bit. Okay, removal. We have what to call. Remember when I say a transitional diagram that let me say that removes, let me put it like this, that removes. This is important, white spaces. It means your compiler, remember you'll be having lines of code, is going to remove the white spaces. So you must have a transitional diagram for that. So do you know how to draw it? No. Let me just check the name, the lim. What does it mean? Because now I forgot. I think it's a combination of white space and I forgot. So guys, if this question comes, you don't know it, all of you. Because now I only have the one for keywords and identifiers. Okay, I found it. Others. Okay. So a delim, it's a collection. It's a collection of white spaces, isn't it? So what this does, let me just say an others, because here you must see others. What this transitional diagram does, you see it has got the 3 states. 1, 1, 2, 3. Now it will search and find some white spaces, and then if it finds more white spaces, it will keep on removing them. Then if it find other things that are not necessary in your code, let's say you placed a comma by mistake, ne? Yeah, it will remove that for you. There are such compilers, right? Or it will just detect the error for you, and then you'll be able to see. I'm sure you have experienced such. Then now, this was a transitional diagram for white spaces on your code. Now we're coming to transitional diagram for what? For keywords. So this is 3 marks and also this is 3 marks for keywords and identifiers. So this one is easy. You'll have state 0. It can receive either a letter, or let me start with digit so that you don't cram. You can have a digit, or this part, your code can receive a letter or a digit. So if I ask a question now, and I ask you, if is this a DFA or NFA, what will you say? It's neither an NFA or a DFA. You cannot really tell here. Why? Does it have epsilon move? Again, but let's not talk about, that's not the real reason. Remember, a DFA, it cannot have more than one input. Again, for a single output, you cannot have an A here and another A there. That's a DFA. So with NFA, that is allowed. So this one, you cannot really tell. It's just a regular transitional diagram. Regular transitional diagram. Fine. Let's move to, what's the next question? Okay, write a regular expression on which the numbers of zeros is always odd. This one will just say 0, 0, 0, asterisk. You are done. Even if here you put 1 and end with 1, it doesn't matter. Then you'll draw a transitional diagram for it. So let's take this one and try to draw transitional diagram for it. Ne? The numbers of zeros is always odd. 3 marks. Yeah, let's use this sensitivity set max 1.4. Is it 1.4? 1.4, ne? Yeah, 1.5. We're now at no, 1.6. 1.6. Remind me to send you this after the class. Yeah, because 7:30 was stopping, so that you guys also check your own things. 1.6, ne? Yeah, I have this combination. For those who don't know how to draw a transitional diagram, now you'll know. Here you'll say state, then you'll say 0, 1. Okay? How many states are going to have? It means you must draw a what? A transitional diagram. You see, ne? State 0, state 1. So this can receive a 1. You're going to have a lot of states here. And let's remove the last one. Let's remove the last one. Let's remove this. So this will be, we'll start at state 0. I want to increase the what? I don't know if this, your eyes too much. Yeah, this is better. 0. I can receive a 1. I can receive an input of 0 on state 2. I can receive a 0 as many times as I want and another 0, and we'll end at state 3. Do you guys agree? I think someone can also extend this, and say, let me remove this. Someone can say you can have another 0 and another 0. Yeah, I think it should be like this actually. And then this will come back here and you'll have an epsilon, meaning you can receive as many inputs. You can always go back. You see, yeah, it should be like this. That's how it should be. The transitional diagram should look like. Did you guys know how to draw this? No one. Yet epsilon move. Do you guys understand? So this is basically an NFA. So I have how many states? 4, 5, 2, 4, 5, 0, 1, 2, 3, 4, 5. Yeah, this pen is giving me a problem. 1, 2, 3, 4. Hey, are you guys still here? Then we only have a combination of 0 or 1. Then you will have epsilon. Then I can remove that. Hey. Yeah, guys, let's finish this up. Then I think we're almost done. So you're going to have what at state 0 can receive. When you are at state 0, can you receive a 0? No. Dash. State 1, a 0? Yes. We'll go to state 1. Okay? When you are at state 0, can you receive epsilon? Yes. You see, ne? Can we have an input of epsilon? This goes to 0, isn't it? Guys, is this correct? Remember, epsilon can also do this there. So this is correct, ne? So state 1, you can have an input of 0. Yes, it goes to state 2. Can you have an input of 1? No. Can you have an input of epsilon? No. State 2, can you have an input of 0? It goes to 3. Of 1? No. Then epsilon, no. 3 for state 0, it goes to 4. State 3 to an input of 1? No. You see, there is no 1 there. When you are on state 3, can you receive an epsilon? No. State 4, this will be no and a no, but it goes back to 2. So this will be the transitional diagram. If you don't understand, you can ask. So now I'm moving to 1.7, right? I'm just going to answer this one only, then we're done. Indicate all the paths A, B, B. I can have that on state 0. I take an A, state 0. A. Guys, let me charge this phone because it's going to switch off. Guys, here. Let me charge this device. If it switches on, charge. Guys, should I continue or you are fine? You'll just come and consult because you are not saying anything. Not sure if we're still on the same page or not. Okay, I think I'm gonna stop the session here. Most of the people, are you guys still here? How many are you here? I think now people left. These people. I think I'm gonna stop this here. People left. Kamogelo.